Well, good morning, good afternoon, good evening. Hi, everybody. How are you? Whew, good stuff. Look at that. It's Sunday morning. Can't believe it. We're here. We did it. Hi, everybody. Good morning, good afternoon, evening. Let's see here. I am, wow. I just finished a good breakfast. Yeah. Okay. So I'm in San Francisco. You know, we have. I'm a little sad, if I'm honest. Today's Sunday, which is good. It's good to be awake. Obviously, you know, any day you can be alive is a good day. But there's a bridge. We have two bridges in San Francisco. Only one is like super famous, but the other one's pretty amazing too. We've got the Golden Gate Bridge, which is, by the way, I don't know if you know this. The Golden Gate Bridge is Azerbaijan. Nice to see you. Hello from San Francisco. Very cool. Look at that. People are from all over the world. We have people joining us today. That's amazing. I'm in San Francisco, and we have the Golden Gate Bridge. The Golden Gate Bridge is it's a bridge over a little canal through which boats can pass to get into the peninsula of San Francisco. So that's called the Golden Gate, that canal, that waterway through which boats pass, right? And so the bridge is called the bridge on the Golden Gate, or the Golden Gate Bridge, right? So anyway, that's one bridge, famous, right? We've all seen the photos. We have another one here, though, that's much more useful. It's called the Bay Bridge. And the Bay Bridge is Sri Lanka. Wow, look at that. That's amazing. Hello. Good morning. Hello, good afternoon, good evening. Appreciate you all joining us today. Sri Lanka, that's got to be closer to tomorrow than it is today by a lot, huh? Anyway, there's this other bridge, and this bridge is beautiful. It's called the Bay Bridge. Hello, Brazil. Viva Patria. Hello from India. My goodness. Look at that. Bonjour. Depuis Paris. Nice to see you all. Good morning, good afternoon, good evening. Everyone in the world here. I love it. Anyway, there's this amazing bridge, and the bridge is used by more people. It's what conducts most traffic in the Bay Area. It's beautiful, and in 2013 they installed lights on top of this bridge, and those lights are gorgeous. They make the bridge pretty, you know. And hello from Turkey. Hello, hi, hello everybody. I love that. Oh, it's so good to see you all. Anyway, it was an art experiment. They were supposed to put those lights there in 2013. They were going to stay there for 2 years, and then in 2015 they decided to make it a more permanent thing. So they extended it forever, you know, but it needs repair. And so they turned off the lights last night. And I'm really sad because now tonight, I guess will be the first night with no lights. I mean, oh, it makes me so sad. I really am sad. Hello from Austria. Hello. Good to see you. From Turkey, we saw. From Austria. Hello. Yeah, people from all around the planet. I love it. Good morning to you. Good evening. Good afternoon. Well, anyway, enough about me. Simon, yes, I suppose. I hope so. I hope did I successfully submit and vanquish the expense reports? I hope so. I haven't heard back, but I just know I will. I should check. You know, that's another Brussels. Hello, Brussels. Maybe they will be new lights. Yeah, that's the idea. The group that is. So it's an art project. It's not like an official function. It's not functional, right? I mean, it's beautiful, but it's art. It was put there as an art project. And so the group that put it there, the private nonprofit sort of group that did it, they're trying to raise money to, first of all, fix the existing installation. And then second of all, enhance it by adding more lights to the other side, and so on. And now those lights are, it would be nice if they succeeded. They're close. They've got like 7 million or something like that. They need 11 million, you know. The lights themselves don't cost that much money. It's the repair and the upkeep and all that. So the lights themselves, I saw somewhere, and it's the internet, so I don't know if it's true, but I saw somewhere that it's like $11,000 a year to power the electricity for the lights. That's it. 11,000 for a whole bridge of like a mile or whatever, more than a mile, length for a year. Anyway, I'm just really bummed out. Good, sad about that. Sad. Hold on, let me open this up. Get some air today. Yeah. Well, anyway, my friends, what are we gonna do today? I guess we have to. Whoops. Yeah, exactly. Hi. Good morning, or afternoon, or evening. I don't know. Hello. Hopefully, it doesn't turn into a painting job like the other bridge. Yeah. I mean, I'm not sure if that's true or not, but I've heard, and you obviously have heard that the Golden Gate Bridge, in order to stay golden, they paint it, right? Although in order to stay orange, they paint it, and they start in the beginning of the year, and it takes them all year, and then they start again the next year because it just has to keep. You have to in an ongoing way. You have to keep doing it. But I don't see people up there painting it, so that doesn't make sense. Bangladesh, my goodness, everybody's here. I love it. Welcome. Hi. Good morning. Good afternoon. Good evening. Small world, huh? We're all so lucky to be alive. But anyway, yeah. How about you all? How's everybody doing? I'll just let me know in the chat. Meanwhile, we're going to continue our journey. Let's see here. Quit that out. For those of you who are just joining, we've been exploring Spring Boot, and we've just been kind of like taking a little wandering, roving tour, going through everything. We started with the absolute basics. So the very first video, we looked at like how to do it the wrong way, right? Public static void main, no framework, no Spring, no nothing. And you know that's the topic of my next video. I've got a video I'm working on about inversion of control, because that original video that we did with this Spring Boot, Let's Code series, it got me thinking, gosh, like, hello from Israel. Good to see you. Hello. Hi. Welcome. Good evening. Good afternoon. Good morning. It got me thinking about that first video. That first video got me thinking about inversion of control, right? And it's such a very important concept in the world of like, any kind of sophisticated software will employ inversion of control, even basic code eventually. When you start thinking about functional pipelines and all that, when you start writing code in Lisp or in scripting languages, or whatever, even just regular Java 8 streams, you start to appreciate the value of inversion control. The idea that you're gonna only work on the thing that matters to you, and let some other thing control the lifetime and the runtime of your of the objects and the data in play. So that was this exercise has been very good. So that first episode was all about absolute basics. What is a framework? We eventually got to portable service abstractions, AOP, dependency injection. Then we looked at Spring Boot's auto configuration. We brought in Spring Framework first, actually. We looked at the basics, dependency injection and wiring and all that stuff. And then we looked at auto configuration. And that's the fourth dimension that Spring Boot brings to the table, beyond the three that I just mentioned: AOP, dependency injection, and portable service abstractions that come with Spring Framework proper. And hello, Badea. How are you? Good afternoon, good morning, good evening. So we looked at all of that, and then we looked at absolute like basics. We built a very, very simple data access layer using JDBC template. We looked at template functions. We looked at JDBC support, and we saw, how all that kind of stuff works together. It's already Monday in Thailand. I know. I love that. I have not been to Thailand for I guess almost 6 months now. No, it was end of October. So October, November, December, January, February. So 4 months and some change, like 4 months and a week since I was in Thailand. I miss it. Great food, great weather, great everything, And then what else did we do? We looked at the web. We started web programming. And that was most of our journey, right? We looked at, everything. We looked at the basic servlet support, how you can register filter beans and servlet registration beans. We looked at this new servlet API, Javax has now become Jakarta. We looked at basic MVC programming. We looked at server-side rendered views with Spring MVC. We looked at basic HTTP, not quite REST endpoints. We looked at hypermedia, which is how you do proper actual REST. We looked at Spring Data Hypermedia, Spring Data HATEOS, HATEOAS, which is hypermedia as the engine of application state. We looked at the design pattern that underpins that. We looked at GraphQL. We looked at GraphQL recently. We looked at how to integrate that with the data tier using Spring Data, and Query DSL. And we spent just way too much time, just an ungodly amount of time working on getting the Gradle build working, right? That was not what I was hoping to do that day. That sucked. I don't like that at all. But it was kind of cool. We got it working. In Maven, it works. I've got an example that's much more readily usable. I'm sure there's a way to do it in Gradle, and it's easy. Question. Good question here, friends. Are JSPs and servlets still used? Servlets are. I mean, if you're using Spring MVC, you're using the servlet API. It's just you're not using it directly. Yeah, this one was a pain to watch, and it was also, imagine, me, it was a pain to be there, but yeah, it's okay. I know it's because I'm doing something wrong, and it would be easy for somebody with some more skill, Thanks to you all, we were able to get some progress. We got it like 85%. It was almost good. It wasn't quite. But the point is, we proved it out. We were able to see it work. We just couldn't iterate in the IDE. So yeah, back to this question: JSPs and servlets. So anyway, servlets are everywhere, right? If you're using Spring MVC, you're using what are the pull requests? What do you mean? Have you seen the pull requests? What pull requests? What did I miss? So if you're using Spring MVC, servlets are underpinning that. There is an alternative, which is the reactive API. And I quite like reactive code, but for this Let's Code journey, looking at Spring Boot, I've just chosen to focus as much as possible on the non-reactive stuff. And the non-reactive stuff is servlet based. So whether you know it or not, you're using Spring's servlet support. And it's kind of interesting that servlet support is one reason why it's so natural to take an existing application and move it to this sort of Spring Boot, right? Where Spring Boot does most of the work for you, right? Spring Boot is the dispatch, the engine, the runtime, etc. It's the thing that programmatically registers the servlets for you and the filters and all that stuff using the servlet engine underneath the hood. And it's still there. You still have a servlet engine, a full servlet engine underneath the hood. And actually, as part of that, recently, I stumbled upon a great example here. I stumbled upon this one. This is not my code. A guy named Andy Wilkinson on the Spring team, who I'm sure you know and who I've talked about a million times because I just think he's amazing. He did this example. Let's see. I'm going to share my screen here. Oops. Okay, share this. Share screen, share. Okay, so he did this example right here. Josh Long, and I forked it. So his original example from 9 years ago is here. Well, I guess most of it is from 9 years ago, but he's got some that's from 8 years ago. So yeah, so you have this like code, and it's Spring Boot 1.0, but I liked it, and I was like, well, this is kind of interesting. So I actually forked it just recently, like 3 days ago, right? And let's take a look at this code, because this is kind of illustrative of the power of using a servlet engine like Tomcat. Oh, by the way, friends, join us on the next version. No, on the next, when does that stream? Is it Tuesday? Whatever. I've got a stream on the YouTube channel. Here, YouTube at Coffee Software. Live coming up. This one. This is coming up. This is Mark Thomas, right? This will be live in 47 hours. So March 7th. So today's 5 March. So that's 2 days from now at 9 o'clock. So basically, like 47.5 hours from now. Okay. And this guy is just an incredible, incredible member of the community. Yeah, so he's one of the people that works on Tomcat, right? Remember, the Spring team has always been the largest contributor to Tomcat. Oh, like for decades, right? More than a decade. Since I've been on the Spring team for 13 years, and that was true even before I joined, because Spring Source, the company that created Spring, at one point they bought, was it Covalent? Covalent, I think, and Covalent in turn had the leading contributors to Apache, HTTPD, and to Tomcat, right? To the servlet container. So the Spring team has always, contributed to both of those projects in large amounts, and we employ people that work on it and so on. And one of the main people there is Mark Thomas, and he's one of those people that's just, if you're using Tomcat, and by the way, most people who are building web applications on the JVM today, most of them are using Tomcat. Even if you're using an application server, more often than not, they're embedding Apache Tomcat. Okay, it's the #1 web container in the world, right? Like so, and he's the one who works on that. So if you are, if you're having success in production, he's a huge part of that. And the thing is, like so many of the members of the Spring team, he just works quietly and does his work and doesn't he's not out there like promoting himself or anything. But I think he's a legend. He's an absolute legend. And so, I can't wait. He agreed to be on the podcast, and I've been doing these videos. I've been doing the podcast interviews live on the YouTube channel now. So crossing the streams. So join us. This is going to be so. Talk to him if you've got questions about Tomcat. He's the person who will know. He's been there for decades, right? Like an amazing contributor all over. He's part of the Apache Foundation. Works for the Spring team. Works for Tanzu. Where the Spring team is. Okay. Anyway, so here's this example from Andy Wilkinson. Another one of those people that just works quietly and consistently and does amazing things and doesn't. There's idiots like me out there who are trying to tell the world about them, about Andy and about Mark and about others, but they don't go out. They just, I don't know. I love people like that. I'm all talk and no. I'm all form. I'm all form and no substance, and they're all substance and less form. And I just think they're absolutely amazing. So I'm so excited. Mark Thomas is gonna be on the show. Join us for that. Okay, that's gonna be great. Bring your questions. It's gonna be a fun interview. So Andy Wilkinson. By the way, he's been on the podcast as well. Andy, if you wanna, has he? I think he has. If he hasn't, then we need to fix that. I think he has. Andy. Well, maybe he hasn't. Maybe he hasn't. Beautiful. That's another one where I would love to get him on the show. No, he hasn't. Look at that. There he is. But there he is right there. He's just he's one of those people that does amazing things just by himself without anybody asking. And every time I think about people that contribute, he's amazing. So he did this example years ago, and I forked it and I updated it to use Spring Boot 3. So let's just take a quick look at that. Okay. Whoops. Oh, it's already cloned. CD Spring. Okay. So idea build.gradle. I took his example in Maven, converted it to Gradle because I'm trying to rock my Gradle foo this year. Let me see. We got some questions here. I still don't know what their pull requests are. Pull requests in your repository from part 7. Sorry. Pull requests. Oh, pull requests. Are you saying pull requests? Oh, friend. I'm so sorry. The coffee. Okay. You're saying pull requests. That's probably what you meant, right? Let me see. Go back here. Okay, let's try this. Did the pull requests fix it? Look at this. I go on the internet and cry, and people fix my stuff for me. It's like the best thing ever. Let's see. Spring. That's code. Okay, let's get status. Okay, RMR source generated. And then what is it? What are these pull requests? I mean, they can't be wrong, right? Simplify Gradle configurations and fix application start from IntelliJ. Okay. What does it do? What does it do? Don't need that. Don't need this. Feels like it would be nice to have that, though. Okay. Okay, what is this? So we don't need this. We do need that. We don't need this. Okay, so how about we try this? Okay, let's just go ahead and try these out. Like, I think we can just do these manually. Just looking at the example here, right? So these are all the changes, right? That's all that is required. So build.gradle. Okay, first things first, we get rid of the configurations. Okay, where's my, oh, wait. No, this is the wrong one. This is my Let's Code. So idea. Okay, there are pull requests. Now I see what you're trying to say. There are pull requests to unbreak my code, which is very kind, more than I deserve. Let's see here. So we've got this open. We've got the pull requests over here. So what are we going to do? We can get rid of that. Okay, no problem. Happy to. Create.sl, don't need that. Goodbye. This becomes just that. Okay, that's fair enough. Let's just do that, I guess. Oh, wait, we don't need this either. Yeah, I don't need this. I had it twice. What? Add that. Okay. Don't need tasks register help. Okay, fine. Yeah, okay. I mean, a little help is nice, but whatever. We don't need the create.sl dependency. Is that this one right here? And the so we do need the APT, but not everything else. So create.sl annotation processor, yes. Create.sl APT dependency management for implementation. I guess we don't need that. What about the MongoDB business? Don't need this. Okay. Yeah. But we want it to look like that. Okay, so that's why we're getting rid of that. Good. And then task name idea. We don't need that. It's gone. And all that is gone. Does that work? Okay, let's try. So what is our definition of success? If we leave things like that, I should be able to start up the Docker Compose instance. Docker Compose up. Hey, how come I can't there you go. Hey, thank you very much for that. I appreciate it. I'm glad you're getting something out of it. That's appreciated. Okay, so it's starting the containers. Now, I guess, what are we trying to do? So, can I run it? I can run it. Okay. But can I run it again? Yeah. What about using it? Okay, let's go here. Localhost 8080 graphical loading. Okay. Well, yeah, okay, that's fine. So what's the issue then? GraphQL schema, customer's my name starting with, and then did we write some data to the database? Yes, we did. A, so oopsies. Oh, why is that? Oh, because I didn't ask for the subscribe. I still don't understand what that's about. That's weird. Okay, that does work. Okay, good. Good. So now what? Does that work? So what is my other test? Oh, let's test it on the command line. So Gradle w boot run. Okay. Same test. Okay, that's working. Let's close this out. I'm going to close IntelliJ, armrf.idea, armrf build, armrf source generated. No, I don't have that, huh? Armrf dot anything? Looks like I'm good, actually. So brand new build, build.gradle. Let's see. So I'm opening up from like IntelliJ, brand new, never done anything. Can I go to the main program, boot 3 application, run? Still works. Yeah, that's awesome. Wow. So GraphQL still there. I'm not doing the work. And look at that, huh? I got an endpoint here. I don't even have to define this, right? That's the whole point, is I can just not define the endpoint there manually, go to the schema here, and as long as the schema has this endpoint, so customers by name, whatever, then it'll just automatically create the endpoint. Oh, that's so cool. So who did that? Oh, that's amazing. Okay, so I'm going to go ahead and roll my changes back, and we'll merge that last pull request. Let's go see what the other ones did, though. This one worked for sure, right? I like, Ramya, you fixed it, man. You fixed it. I appreciate it. Thank you. Okay. So how did we? Wow, I can't believe it's fixed. I was not looking forward to today's adventure, just because I thought we are gonna have to like undo, everything. So let's see. Wow. Okay. Merge pull request. Okay, there we go. So now I can get pulled latest changes. Okay, whatever. I hate what's going on with that. Good. Okay. That's like best news ever. Let's see. Idea build.gradle. So, that's so good. So why is, okay, let's see. There you go. It's fixed. Look at that. IntelliJ is happy. Gradle's happy. Spring Boot is happy. Java is happy. Everybody's happy with what we just did here. Thanks to Ramel. Thank you, buddy. Thank you so much. I learned something. So I don't quite understand. Let me see if I can understand. Okay, I've got repositories. Great. I've got this configuration for the annotation processor business, which this is not the graph. This is not Query.sl specific. You need this even for like Lombok, right? This is just anytime I see an annotation processor in Gradle, I see this basically. And I don't know why that's not just done automatically, but okay, so fine. When you see the source sets, what are we doing? So why are we doing? We're telling it we want to include the generated folder as part of the Java source sets for this build. That's fair. That works great. We have used the cleaner syntax to bring in the Query.sl MongoDB support, and we're excluding this driver, Mongo Java driver dependency. Nice, very nice. Okay, I'm learning. This, it looks like, it's fine. Okay, bring that in. Does that mean I don't need to version manage this? Is that managed by Spring Boot? It probably is. I don't even know. Whatever. Leave it alone. It works. But let's see. I mean, all I'm doing is, if it's already version managed, it's probably not. That's probably why I didn't build in the first place. But I'm just bringing in the version that Spring Boot specifies anyway. So it's not like I'm wavering or differing from the defaults. But this is really nice. This is very, very concise, much more understandable, and also much more understandable compared to what I was doing with Maven, for example. So, and since you fixed it, I don't have to use the double quotes anymore. I can use single quotes, which means, because I'm using double quotes here just because I want to do string interpolation. That's it. That's all I buy, and it's kind of confusing, but it's nice that Groovy supports both syntaxes. Both. In Kotlin, for example, there's only double quotes, just like in Java. You can't use single quotes for strings. This is kind of like, I think Python, same thing. You can do double and single quotes, and it's not about string interpolation, because if you want to do format strings, you do F quote, whatever. And then this is just default stuff as well. So all you did is get rid of stuff. That's a great improvement. That's great. So happy. Okay, well, we can just keep that in then. Life is good. Let me see what the other ones did, just because, I mean, I know Ramil was like on top of it and fixes stuff for me. This is the story of my life, by the way. Like, as much as I try to learn, most of my life is just standing on other people's shoulders, asking them for help. Or sometimes people take pity on me and they just help me proactively before I even know I need it. And I love that. I love it. The internet is great. No commits found. Oh, well, I must be missing something here. Commits. Update no Gradle. Okay. Looks like they did something similar. Okay. Oh yeah, look at that. Source main Java. They got rid of this. Looks like they were okay. Looks like this was on the right path. A lot of the same broad strokes. It looks like. Source. I didn't know you could do this. That's interesting. This is like properties versus YAML. It's not YAML. It's like JSON. But I like that. Is that real? That works. That's cool. I wonder if you could do that in the Kotlin DSL as well. I don't know. Okay, so that looks like it would have gotten me very close. Thank you very, very much, Ideki, Nathaniel. Let me see. How do I conversation? What is the other pull requests? I want the closed ones. This one. Okay, so that's a good pull request. It looks like. Well, it's not. Oh, that's an ugly icon. I wish it wasn't so ugly. I closed it with thanks. I wasn't like it was denied or anything. It's just redundant. You know, I don't need it. I already got the other fix. Okay, so there's another one. Obs. Okay, I need to have annotation processor. If you want to have. So this is a quick fix for build.gradle commits. Okay. Seems like everybody's fixing my my source sets. It seems like that's part of it. Okay, so I think this one. Okay, that makes sense. But yeah, thank you for that. Let's see, conversations. To this one. Okay, so there we go. Very okay. So good. So we made progress. I mean, you made progress. I'm just along for the ride. I appreciate that. Okay, good. So our code is better actually. Let's see. So back to these questions here. Pull request. Oh, that's so cool. Pool. I was so confused. The coffee hasn't kicked in. It's early in the morning. It's only 9 o'clock. So that's good. To expand on, so to another question here. In the last part, we did GraphQL using QueryDSL. Is there an alternative? I think there's an alternative. What's the alternative to? There's QueryDSL, and there's another one, and I forget what it's called. But QueryDSL is the one I've known about for years. I forget. It seems like every other week there's a new type-safe query thing based on annotation processors. So the thing is, I'm having trouble remembering whether the thing I'm remembering is in Spring Data or if it's just outside of it, right? Either way, I would just use QueryDSL until I've got a reason not to, right? As bad as our journey was trying to make this work with QueryDSL, with the sparse documentation for MongoDB and Spring Boot 3 and all that, as bad as that journey was, it's still the most widely used alternative, the most widely used implementation of this kind of paradigm, of this annotation processor generated type-safe query thing. So I would hate to go into strange unlit places of the technology stack with other approaches. At least this one has a larger community. Okay, so expand. So and that's a part that was in response to this great question. So to expand on JSP servlets is Webflux. The way to go in Spring when working on something new. SAM in a vanilla environment, a lot of Spring niceties still seem Servlets MVC specific. So I like reactive programming. I think it makes sense. It gives me 3 big benefits that I think are worth preserving. That said, first of all, you've got to make some pragmatic choices here. How are you going to hire? Who's going to work on your code, right? Do they know reactive programming? Because it takes a little while to get used to it. And if you have to get something out the door tomorrow, then maybe your priority isn't that extra, those extra benefits. Maybe you just want to get something out the door, which is fine, right? So and with Project Loom coming, Project Loom will give you 1/3. It'll give you 33% of the benefits of reactive programming, and that's a big one, which is the scalability. So if you are willing to use, my answer is, go ahead and use MVC and servlets if you want to, but only do it with the intention of moving to Project Loom. Otherwise, you're sabotaging yourself. If you're in an environment where you still have to use Java 8, then absolutely do not use the servlet stack if you have access to the reactive one instead, right? Reactive is way better for you. It's going to be a lot better. You get better scalability. It's faster at runtime, better performance, better composition, et cetera, et cetera, et cetera. Okay. How come Reactive Spring is not, okay, good question. So how come Reactive Spring is not using the Servlet API and it uses web, so it must use it, right? Underneath the hood, the Servlet API is a blocking abstraction. There are some parts of it that give an opportunity for you to do things in a non-blocking fashion. Basically it's impossible to write code in a reactive fashion using the servlet abstraction, right? And so in order to allow people to write non-blocking code, the world created the reactive specification, and that's a totally different way of thinking about pipelines, data pipelines. And so it doesn't use the Servlet API because the Servlet API is fundamentally incompatible. That's why I say Project Loom is a big deal, because it gives you 1/3 of those benefits of reactive. And that 1/3 is non-blocking IO. Okay, it does it through magic underneath the hood, which I don't even I don't understand it. It just looks amazing. I cannot wait to have it, right? So it doesn't use the reactive API. The reactive API doesn't use the servlet API just because they're fundamentally two different things. That's like asking, why doesn't green use red? They just don't. But it is possible to use. It is possible to have reactive. So here's what's possible in the servlet stack. They introduced something called an async response recently, right? In the last 10 years, servlet 3.0, maybe 3.1, I don't know. And that mechanism allows you to take advantage of some non-blocking facilities, but not everything. So like getting a cookie or a session is still going to be a blocking operation. But if you're willing to write code in a certain way, then you can take advantage of this. It's just not very convenient. So the reactive API makes it very convenient to write non-blocking asynchronous code, as opposed to creating a future, right? And then returning that and handling the threads and all that stuff for every single response, for every single data access layer, for every single bit of code. You have to do threads and futures and all that stuff. It doesn't compose nicely at all. But so underneath the hood, we can fake it. We can make it so that when you write code with the reactive API on the class path and Tomcat, we'll use Tomcat, but we'll let you write reactive code. So it's the other way around. In this case, the Tomcat, you're using reactive on top of Tomcat, kind of. Let's see. Can we become a member of the Spring team? Yeah, I mean, I talk about this all the time. There's GitHub issues, github.com. If you go to github.com spring-projects, look for any of the projects, and a lot of them will have open issues called ideal for contribution. There'll be tags in the issues that signal from the Spring team members that, hey, this project is something we wouldn't mind mentoring somebody. Usually they're small, lower level issues that let us work with you. We can try and mentor you. They're small issues that are easy enough that we can do it. It's not like the people on the Spring team don't know how to fix this, right? The solution is all but guaranteed to look like a certain thing, and we kind of have an idea, and wouldn't be hard. But if somebody wants to work with us, and then we can interact with them and see how their code quality is and what their attention to detail is and all that stuff, we can, it's an opportunity for us to work with you and to know you a little bit better. And then maybe if you decide to send more pull requests for other issues, maybe we'll be interested in that too. It's just a way to become slowly a part of the team. And that's what's so nice about GitHub, is that social programming aspect. Okay. So wait. Is there anything special of Spring Boot 3 or Spring Framework 6 about Kubernetes? Well, I mean, so Spring Boot 2.4 and later all have great servlet support. So 2.4, 2.5, 2.6, 2.7, 3.0, you know, they all have great Kubernetes support. They all have Docker support. So there's build pack support. I showed you all that. You know, we could actually, that's a good point. We have an application today already. Do you want to get it like, I wonder how hard that would be. I would need to set some stuff up. Oh, I probably can do local. No, but I can't do the build pack, so that'd be interesting. Maybe today we could talk about containerizing things. Yeah, might be interesting. I don't know. Let's think about that for a second before we dive into it, but could be good. So no such thing as a silly question, my friend. I appreciate it. Express versus Spring Boot. What is more fast and performant? No idea. It depends on a million different things, right? But in general, which one do you want to build a large service with, right? For me, the answer is obvious. I want a statically typed language like Java or Kotlin. I want something that's been shown to work at scale. The real answer here is Spring Boot is performant enough, right? So hold on, there's a ambulance or some police or something. I don't know what's going on. The real question is Spring Boot performant enough? And the answer for the largest websites on the planet is yes. Yes, it is. So for example, what's a good eBay? eBay is a auction and a website, right? They use Spring Boot, right? And they've talked about it publicly. And they used to use Spring. Now they use Spring Boot. So it's been a long part of their stack for decades, right? And it helps them handle the largest transactions, one of the largest websites on the planet. What's another example? Tesla. You know, they have job openings for Spring Boot users. So that's their. What about I think does Amazon job openings Spring framework? Let's see. Well, Glassdoor, Amazon Java, Spring. I'm pretty sure I heard that they might be using it. I don't know. I don't want a job. What do I consent? Block. Go away. Spring Boot. Just look for Spring. Search it. 94. Okay. What's a Seattle zip code? Here's this one. Not what? 98105. 98105. Okay. If I want a warehouse associate job, then there's lots of that. These are not the jobs I'm looking at. Okay, Spring Boot. Yeah. Okay. Well, yeah. There's no jobs that I can find. Pretty sure they do. I've heard things, right? Does Amazon use Spring? Oh yeah. So there. This is 2019. I don't know if it's still. Oh, it's Blind. This is the app that people can use to submit things anonymously from different companies. So like Twitter, you know, they use Blind to complain about Twitter, right? But anyway, there's a lot of Spring in Amazon. Okay, so I don't know. So that's using it. What else? PayPal, I think, is using Spring Boot. Does PayPal use Spring Boot? Whatever it does. I won't be able to find a good response here, but you know, that's part of eBay, so I think they do as well. What else? What else uses it? Netflix. Netflix is, you know, hundreds of millions of customers. They use Spring and Spring Boot everywhere. They've been part of our keynotes and all that stuff. Alibaba is the largest e-commerce. Like, forget Amazon. Alibaba is the largest e-commerce engine on the planet. Billions of users, you know, and they break the records all the time. Like they have 11/11 Singles Day, right? Which is the November 11th, which is it's like, how we have Cyber Monday and Black Friday and all that. It's a sales holiday here in the U.S. In the Chinese diaspora, they have 11/11 Singles Day, and it's a sales holiday as well. It's just a way to get discounts on things. And every 11/11, Alibaba and all the companies underneath it generate more in 24 hours than like Amazon and eBay and all these other companies combined do for Cyber Monday or whatever, right? It's absolutely insane. How much did 11/11 2022 sales Alibaba? Let's see. Singles Day. Okay. So let's see. Rivals of it. In 2021, Alibaba and JD reached a new combined Singles Day record of $139 billion in 24 hours. So, yeah, like that's a lot. That's a lot of money, right? Like in a single day, that's an insane amount of money. So, and that's all powered by Spring. Everything at Alibaba is Spring. Taobao, which is like their what is it? Taobao is their like B2C, I think, and then you have Aliyun, Alibaba Cloud, and you've got Alibaba itself, and all those things are Spring Boot. So the question is, does it matter? Like, I don't know what the performance is in your particular use case for Express versus Spring Boot, but for the largest websites on the planet, they're using Spring Boot just fine at scale. So you'll be fine if you choose that, right? Your problem will never be is Spring Boot too slow, right? That's not the problem you're going to have. And then if you start using things like GraalVM native images, now I know for sure it's going to be a lot faster and more efficient, right? That's going to be very, very small, very, very fast, etc. And if you use reactive code, then you're getting even faster, right? Even more efficient. So it's a good deal. Generated new build. You are welcome. Thank you. Do you know why the QueryDSL site is HTTP instead of HTTPS? I don't know. Oh, Apple uses Spring. Is that true? Okay. Apple jobs Spring Boot. Yeah, Billy. Yeah, this is a job at Apple. It says jobs@apple.com, and it says strong object-oriented programming design experience, including Java. Second, Java and Spring Boot. So yeah, they use Spring as well, and that's also one of the largest websites on the planet. So trust me, your problem is not going to be Spring Boot. You'll never develop something where people are like, "Oh, Spring Boot's too slow." That's not the issue. It's what did you do in your code? Are you doing something inefficient and ugly? If you are, then yes, that's probably going to be a problem, right? That's going to be a blocker. That's going to cause you to scale poorly. And that's the same for Express as well. As good as Express.js is, if you don't know what you're doing, you're gonna have bad results. So where are we, my friends? Let's see here. Close all that. We're back to this. That's cool. Yeah, look at all that cool stuff. Okay, friends. So what I'm gonna do, I think today, I kind of like the idea of talking about deployment and packaging and all that. I kind of want to see what would happen if we do QueryDSL. Maybe I'm asking for too much. Today, speaking of efficiencies and whatever, Spring always feels less choose your own adventure compared to Node and Express. Yeah. Although I don't know if that's actually. I mean, it's. So this gets us back into the discussion I was talking about earlier, where I was alluding to the idea that you have. Hold on, I need to turn this down. This gets us back to the question of a framework, right? So remember, Spring is a framework, and we have inversion of control. And with inversion of control, the life cycle of resources is managed by the framework, and it involves you only when you can contribute something meaningfully different from one application, like the business logic, the thing that makes your application special versus the rest of the code, yeah, exactly. Spring Boot definitely has more dependencies that fit together cleanly through common interfaces. And we do try and steer people to those very, it's not like a whole, it's not like the whole internet is supported. It's not like we support every technology ever. We have strong opinions about different ideas, about different approaches, but they're loosely held. So we want you to use something like the repository pattern or a template pattern for data access, okay? But we don't care if you do it with JDBC or if you do it with reactive non-blocking, or if you do it with MongoDB or Couchbase or whatever. So we make it so it's very easy to understand. And it's because it's a framework, right? And it's because it's a framework that we write the code in such a way that you are only bothered, you are only involved, only prompted to act when you need to contribute something that is unique to this business logic, right? And that's, if you think about like the code, Valhalla and Loom will probably improve the speed of Spring Boot by a huge. So again, Loom will improve scalability of servlet-based code. It won't improve reactive scalability, and it certainly won't improve performance, right? The performance is fast enough, right? Did I deliberately skip your question? No. What question? Let me see. There's just a lot of questions here. Have I ever tried Micronaut to see how it compares with Spring Boot? Just use Spring Boot. I don't like, yeah, I don't even know what I'm supposed to do there. Let's see. So Valhalla and Loom. Yeah, Valhalla is also very interesting. Valhalla is Java, right? Where's the it's the value prop? It's the values as a first-class thing. Java. Where's the Valhalla? So this is going to be a big deal. This is for free. This will help everything, right? Project Loom will help servlet-based Spring MVC code. And actually, to speak about that, there's a great. Remember, I mentioned Mark Thomas just like half an hour ago. Mark Thomas just did a blog, and it doesn't feel like it was there. This is February 27th. So we're on the 5th right now. So this is like 7 days ago, 8 days ago. It's not that long ago, right? And basically, he looks at Project Loom, and he says, okay, well, it brings high throughput, lightweight concurrency to the JRE, virtual threads, and it basically, lots of great information here. I encourage you to read it and encourage you to see, and he's low-level Tomcat, right? So it's fine. But basically, the conclusion is, where's the rest of the blog? Where's the... Oh. Long-term, web applications that have switched to the servlet, asynchronous API, reactive programming, or other asynchronous APIs are unlikely to observe the measurable differences, positive or negative, by switching to a virtual thread-based executor. So longer term, the biggest benefit of virtual threads looks to be the simple application code. That's fair. And some of the use cases that currently require the use of servlet asynchronous API, reactive programming, or other asynchronous APIs will be able to be met using blocking IO and virtual threads. So that's going to be amazing, right? Okay, let's not turn the, like, one thing I do not want to do is have a pissing competition in this chat about, this, that, or whatever. Let's just keep it on Spring. So Project Loom is still in preview mode. It's too early to be considering using virtual threads in production. I mean, you can use it. They're out. It's just not, it's not yet GA, right? And I definitely encourage you to try it out. Maybe don't go to production with it yet if you don't want to. I can understand some hesitation, but it's already there. You can already try it out. You can just do -- enable preview, and you can use these. You can use Project Loom in your code today, and there's well understood hooks. Oh, that's what we were going to talk about before. We were going to talk about this. Oh, I'm so excited. Somebody fixed my code for me. That's the best feeling. But we were going to talk about this, which is, this is the code from Andy Wilkinson. And what I wanted to show you was that there's, for things like JDBC, Loom is great. For things like the Servlet API, Loom is great. Loom is great. I have absolutely no hesitation in saying I'm very, 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 very excited about Loom. Loom is going to be a huge deal. And also, it means that you can write relatively inefficient code and it still gets free scalability improvements, right? Not robustness. right? Not composition, not cleanliness, but it'll still be more scalable. And that means that you can take these old apps and they'll just become for free, right? They just become more scalable, which is, wow, you know, that's absolutely crazy to me. It's just crazy what they have done. I'm so grateful. It's a hard trick to do. The only other language that I know of that has done that is Go, right? The only, because if you think about it, like we have, move this to here. The only language, let's close that out. Okay. So Go has this thing called channels, and it's got basically non-blocking I/O, but it was built with it from the first version of Go. So there was no, they never had an alternative. They did from the very first version what what Java is doing right now, right? But the way that like if you think about like JavaScript, okay, let's think about the JavaScript world. Remember 2009, right? Rust reveals new constitution in wake of crisis. Okay, that's going to be something I want to read, but not right now. Okay, so if you think about 2009, like again, a long time ago, like 13, 14 years ago, everything was callbacks, right? So you'd have like a, you know, make request, and then you'd have to send a callback result, and then you'd make another request, and then you have you know, function, another result, and it just got very, very painful, right? And you had these callback hell, and so people even joke about that. I see people's Twitter profiles. There's like stuck in callback hell since 2009 or whatever because they're JavaScript developers. Well, of course, nobody does this in JavaScript in Node.js anymore. This is gone. It's dead, right? You can, but that would be very inefficient. And if I see that in my JavaScript code, it tells me I'm using an old API. Right? Since then, they all had this, right? So instead of this, you do dot then, right? And you could, you then be like the React API, right? So result, and of course by this point you also have metas, right? So results console.log or whatever, or make another call, right? You could do promises. Oh, that's not that anymore either. But they had message chaining that kind of looks like React does today, right? It's instead of nesting, you have the ability to do a, you know, call dot whatever, b whatever. You could just make these calls in perpetuity, and you'd have a pipeline of like futures or promises, they call them. Okay. Much better than Java futures, okay? And that's like reactive APIs, kind of, in the Java world, more like a publisher, actually. And then eventually, they built it into the language. So C#, Kotlin, Python, Rust, JavaScript, and of course, TypeScript by association. I'm sure other languages as well. They have async await, right? Actually, Kotlin has suspend, right? This is the only language that has suspend functions. But basically, in this approach, you have to tell the language that something is going to be non-blocking. So you have to say this is a async function, you know, foo, and then you do something in there, and if I wanted to use it, result, I have to say await foo, right? So all of my code is painted with these two keywords. And if I don't have those keywords, then I can't do non-blocking things. So I have two branches of my code. And of course, the main root function, eventually, you realize you have to make that, you know, it has to be async, right? Otherwise, you can't call other async code. You have the top level context has to be set up, basically. And so this becomes, they call this the striping problem, right? Where your code has like, half of it is painted with async and the other half is painted with non-async. And so they can't interact with each other. And they end up becoming more mutually exclusive. If you're using reactive APIs, then this is not a big deal. You can use reactive APIs in Spring and use Kotlin. And it doesn't matter because it's all reactive. So there's no like, if you're using it, you don't start thinking, oh, I'm going to do non-reactive code. It would be very weird. You don't ever break out of that context. But for these other languages like Java and which doesn't have it, or Rust and JavaScript and all that, you've got all this like stuff where it's half the universe supports reactive and half doesn't, right? Or supports async await. So with Go, like I said, they just did it the right way. They got it right so it's only non-blocking, and that's all you got basically by default. That's a little simplification, but it's true. And with Java, they're doing the hardest of all possible solutions, which is, I mean, not for us, it's the hardest for them, for the team working on Java. They're giving us non-blocking I/O with existing blocking interfaces, just like Go, but they're doing it, almost 30 years after the community and the language was born, right? They're introducing it into Java, which is already a very rich, mature ecosystem with, billions of lines of code written in it, and they're doing it retroactively while the plane is in air. They're swapping out the engine. It's just amazing what they're doing, just an amazing. So, and that's why it's taking a little while to do this, because it has to be done very, very carefully. And we're very lucky. I mean, this is gonna, like you just said, it'll make Java just a better place, and it'll make Spring a better place. Of course, it'll be good for everybody. Okay, so let's talk about this. And by the way, what I'm saying is they're avoiding this painting problem, right, in Java, and I think that's, for a lot of cases, that's going to be a good thing. So yeah, I can't wait to see that result. Let's talk about this example here, friends. This is the Andy Wilkinson thing, and it's a very trivial example, but I wanted to show it to you because it kind of reminded me of what's so nice about having a framework, and what's so nice about having a framework in particular, using Spring. Okay, using okay, I didn't even play with this last time, so let's move this up here. Okay, get rid of that. So there's a simple piece of code here. Oh gosh, this is so old. I didn't even fix this code. I didn't even bother. But private final data source into the constructor. REST controller. Okay, there's this. We can call this, what do we want? Data source. Data source. So what is he doing here? So he's returning a string. Okay, get mapping. Okay, there's that. Okay, so this is a pretty trivial example. Import that class, import that. This is a pretty trivial example, and it's a framework. Remember, frameworks, they sit on top of your code and involve you only when they're required, right? So okay, you want to do a response entity? No problem. I can do that too. Response entity. Yeah. I'm not sure if that really popped much here though, but you're right. It's probably a better idea. Always good to have that response entity there. Okay, so okay, good. So we have this simple controller, and the idea was, actually, I created something that did the same thing. We don't even need this anymore. I didn't realize, to be honest with you, I didn't remember that he actually had this. I didn't even look at this the first time. So we'll try it now. But basically, he's got this. He's I even made it work. I made it work with the Gradle VM as well. Basically, what this does is it uses a Tomcat servlet web server factory. Okay, so I'm creating a bean of type Tomcat web server factory, Tomcat servlet web server factory. And I'm using it to programmatically register a bean in something called JNDI. So if you think about like terrible code, the worst, let me think about it. Where's a good example here? Open, desktop, Miss Hollywood principal, Hollywood. Open as a project, right? I think about this a lot, right? So DI, do I need that? Here's, oops. Where's my manual? So here's the works code, right? This code is written in such a way, it's an implementation of a customer service, and I have to provide a JDBC template, and so we manually create the data source, we create the JDBC template, and then we return that, and we're doing it all in the private static method of this class. there's no way to swap out a different implementation. There's no way to, this is connected to that database every single time. It's gross, right? And so we talked about this before. We talked about something in the first video with the Spring Boot. There's a slightly better way to do it. Not good. I don't like it at all, but it's better. And that is to use JNDI. And so here, JNDI is a context. It's like a map. It's a dictionary with a network service. So basically, you can stash objects there. Okay. And so here, we can assume that we've got a context. We can look up the data source this way. So we can say new initial context, and we use the initial context to look up the value in the data source, right? In the context, and we get the data source back, and then we create the database template ourselves. Now this is gross. This means that our code is still tied to JNDI, which in this case it doesn't need to be. It's not. The idea was that it used to be that you might want to share a data source with different apps, right? Which is a anti-pattern. You don't want to do that if you can avoid it, right? But anyway, you might want to have a connection pool managed by your web container, and that's still a thing that people did. And maybe even if only for compatibility, you might have something like this. So it's nice to know that you can move your application to Spring Boot, but you still want Tomcat to provide the data source. I don't know why you would, but it's still possible to do that. So that's what we're doing here. Is we're programmatically registering the data source. So if you've got code that it has a hard-coded dependency on this data source URI for Tomcat from actual servlet-based Tomcat deployments, then you can recreate it so that it still works. Oh, thanks. That's very kind of you. I appreciate that. I'm nothing. I'm just a loud clown working on the Spring team. They're my guys. They're awesome. They give us more than they take. So anyway, you can recreate this. This context. You can create the JNDI entry by manually instantiating the context resource and installing it in the context in Servlet. This is like server.xml for Tomcat, but you're programmatically setting it up. So I say, give me the context, get the naming resources, add this resource, and I'm cheating. I'm using the Spring Boot properties for the URL, the username, and password. But you could get it from wherever. Hi, Jorge. Today we're just kind of reviewing the state of things in the web container layer. When we started the stream, we had an amazing, what is the right word? A gift, a very generous gift. It's not even my birthday, Actually, I appreciate it. You know what? I'm going to take it as my birthday because my birthday was on the 31st of January, and on the 31st of January, I tested positive for COVID. Worst birthday gift ever. But so this is this is the gift I wanted. This is cool. So Ramil fixed my bugs in the Gradle build. So that's working now. And then we went off on a little bit of a tangent. And I'm talking about how, you can use the Servlet API and how the Servlet API is actually a huge part of what you're doing when you use Spring and Spring MVC. And then we talked about Project Loom. We talked about some of the amazing opportunities for Spring MVC users. We talked about reactive versus imperative code and some of the benefits there. And now we're just talking about this piece of code that was originally written by Andy Wilkinson about 9 years ago, and that I have then upgraded. I've updated it to use Spring Boot 3.03 instead of Spring Boot 1. Whatever. And I rewrote it to use the new version of this interface because now there's reactive API, so they had to bifurcate that a little bit. And I'm talking about how you can use this abstraction, this interface, to programmatically create entries in a JNDI context. And then Spring can resolve that bean for you and make it available as a data source. So here, we're creating a data source, but we're looking up that data source via this JNDI entry, right? So this is the JNDI factory, JNDI object factory bean. This has been in Spring, for decades. What is it? Since 2003. Actually, for 20 years, basically, almost 20 years. 19 years and 2 months, right? 19 years and 10 months. We just have 2 more months, and then it'll be May 22nd, 2023. So this has been here forever, and it's just a factory bean that lets you look up objects in a JNDI context, and then inject it. And so your consuming code doesn't need to know that is coming from JNDI. So you can rewrite this terrible code over here, right? Well, not this one. This one. You can rewrite this terrible code so that it gets its data source in the configuration as just a javax.sql.data source. It doesn't have to know about JNDI, it doesn't have to know about Postgres, it doesn't have to know about any of that. And that's the ideal situation. That configuration lives in the wiring layer, not your business logic, right? And that means you can now unit test it, you can swap out for different dependency, or better yet, you can get rid of the data source from JNDI altogether and just use, create the bean directly here in Spring instead of using Tomcat to create the bean, right? There's no point to do that. Okay, so anyway, this is pretty cool. Like, this is actually kind of an interesting example. So we're using Spring Boot, but we're using Spring Boot and we're using the embedded Tomcat, and we're using Tomcat's JNDI context to create the bean for us, the data source. And then down here in the application code itself, from Spring, we're consuming the data source from JNDI. So if you have servlets or code that needs to talk to, it was built, in another time and place, and it was using JNDI, and you can't change it to use regular Java dependency injection, then that's no problem. You can use this embedded servlet Tomcat factory thing to programmatically stand up JNDI context, contribute data sources for it, and then you can consume it from that, just in the same way. So now your code will work in the same way. Just very, very convenient, right? That's one of the nice things about using Tomcat is it's just such a powerful, flexible thing. We're using an embedded Tomcat. It's programmatic. We're actually writing Java code. Spring Boot writes Java code to create an instance of Tomcat as a server, and that's what you're using when you use Spring Boot to start a web. You may know this. I mean, yeah, the advantage of JNDI data source is that you don't need to store the username and passwords anywhere in the code. You shouldn't do that for Spring Boot either, right? Like, I show all the time, I show people how to do this, but that's another good point, which is Spring Boot has this environment, right? And the environment abstraction lets you keep this stuff outside. So this is just for like development. But if I run this code, let's say, let's create a value here. Test equals hello from properties, right? So I can, and then I'm going to create a little controller here. Where's my sample? Create a bean here. At value. This is this one, this one, this one. So it's called test, right? So the test like this, string test. And I say return args. The value is, okay. So I'm injecting this property here. So when the application starts up, it'll load the value and it'll print it out. Oh, my table doesn't exist. Am I not running Postgres? Schema to SQL. Why did it fail to run that? Oh, drop table if exists. There you go. So let's try that again. Different port. Yeah, of course. Our let's code is here. There we go. So the value is hello, and that's from the properties. But now let's say I run this on the command line and I want to override that. So I'm going to value is okay. So now I'm going to run this from the command line. Spring Boot, JNDI, and I'll say Gradle boot run. But here I'll say export. What is it called? Test? Is that the property file? Test, yeah. So export test equals hello from env, right? So I'm creating an environment variable, and I'll do Gradle boot run. Okay, there you go. So you can see the value is now hello from env, right? So that Spring Boot will automatically honor environment variables that match properties. So this is capital TEST. This is lowercase TEST. But if I did, I could do the same thing here, right? I could say, I could do this property. Let's say fan underscore So then you make that an environment variable. You can say, okay, I want to export this instead, right? So, whoops, that Spring export Spring data source URL equals hello, right? And you could set it to be whatever you want. And so the point is that could be your production credential. It doesn't have to live in your Java code. You should never ever have access to the passwords and so on for your production database. That should be set up in the production environment that runs the actual Java process, in the container more likely. And you can do that with environment variables. So the operations people who are in charge of setting up those environments and all that, they can plug that in, and your code can just use it automatically. Okay, so anyway, yeah, I love this. I love that you have this incredible support for Tomcat, which is why, like I said, you should definitely come to see that episode we're going to do with Mark Thomas on in 2 days, less than like in like 47 hours. He's going to be on the show 46 and a half hours from now. Is that right? Yeah, that's right. So, yeah. Anyway, this is a very cool example. It sets up a data source. I even made it work as a GraalVM native image, right? So I had to register a couple of hints here for that. We created the data source itself. We injected it, and then here in the controller, let's see if this works. Let's run this. So run the main application. Oh yeah, you're right. I mean, it's one benefit of JNDI is that you can externalize that configuration. I don't think people should be using JNDI at all, ever. Like, there's no reason. But if you have code that you want to move to Spring Boot, but it's got a hard-coded dependency on some sort of JNDI context, then you can still get around that, right? Thanks to the very flexible, pluggable nature of Spring Boot here. Okay, so 0.894 seconds to... Oh, gazoon. Okay, so we have I sneezed into my own hand. Gross. Yeah, I like this example. This is very interesting, and it shows how flexible Tomcat is. Just an amazing piece of the stack. And hopefully you never need to know about this. Hopefully you don't have to care. But it's just nice that you can do that, Okay, so my friends, let's close this out. Let's close this one out. Oh, let's hit the endpoints first. I want to see what that does. I didn't even realize this endpoint was here before. Localhost 8080/factory. Okay, cool. What does direct give me? What does that give me? Data source. Oh, so if we look up the bean using direct, okay, I think this might have been easier just to map. Okay, so we'll say return object. Okay, return map.of direct, and this will be here. This is data source. And then this is this one here. This. Okay, so let's just do some comparisons here. So we're going to look up what bean we get via, if we do the lookup with the initial context directly, or if we just inject it via the factory bean that uses the JNDI factory bean that will, we should have the same object from here. It should be the same memory, same object, same reference. Okay. Okay. Let's try that. Oops, what did I do wrong? Oh, Okay, let's just create an object here. Yeah, that's fair. So there you have it. If you look at the data source is 58F. It's 58F, A62D, A62D. So it's the same bean in both cases, which is convenient, right? Very, very powerful mechanism. Okay, and actually, I think that's such a useful thing. Let's just move that over here to the customer HTTP controller, we'll call this REST controller, class data source controller. Just put that in there. We'll just inject the data source directly. Okay, and we can get rid of that separate one. Delete that. Stop this. Rewrite. Get status. Get commit. SA. Simplify data source controller. So the question is, I wonder if there's something similar for LDAP auth with JNDI realm. Maybe? I don't know. It looks like you could. I'm not even sure if I understand the question. So you want to do authentication using LDAP, and you want to configure it. You want to make it accessible from JNDI. I think you can do that. I don't know how, but yeah, you could. Okay, so good. Where are we, friends? I think we're good. So let me close this one out. I made my changes to that. I feel like the code's better for it. But let's get back to our journey. I'm actually kind of excited now that we've gotten this. What's the difference between this and what we had before? Oh, I just added a space. Okay, well, whatever. Okay, so we have our Spring Boot application, Spring Boot 3. Oh, no. Oh, it doesn't work. Oh, no. What did I do? Let's see here. It doesn't, like the code is broken. But I can run it. So it still doesn't quite, wait, what? Look, I just reran it and it works now. That's some interesting stuff there. But whatever, as long as I just have to run it and it works, that's fine. Okay, so there's the code. When we left off, we used Spring Data, and we had created a cell. We had, I guess the next question is, how do we package this up? How do we make it more? How do we get it into a shape? I don't know. We have like half an hour. Like, let's say we have half an hour. What do you want to talk about? Do you want to talk about packaging? Do you want to continue tugging at data access stuff? Do you want to continue? Do you want to look at GraalVM native images? Maybe. Do you want to look at? I don't know. I mean, Kubernetes in particular, Kubernetes features. We can start to talk about making your services more production worthy using the Actuator and stuff. Yeah, IntelliJ hasn't had its coffee yet. Again, it's one of those things where 99% of the time, it's me that has screwed up something. So I love my IntelliJ, but yeah, every now and then, once a year, twice a year, it does something like there's just no way that's right. Kate, you want to do Kubernetes? Me too. I like Kubernetes. Okay, let's do it. Where do we even start with that? And we have to come back. We're not done with data access, right? We have to come back and revisit it, but we just don't have enough time in the next 30 minutes to really come in and do a full data access course. Although maybe I shouldn't. Maybe we don't do that in the Spring Boot tour, right? Maybe because we've already done data access with JDBC template and Spring Data, and we looked at Spring Data REST, and you got the basics, right? And this is a Spring Boot course, not a data access course. But maybe I should do something special for data. There's just so much to it, But one of the things I want to talk about next, maybe we forestall the actual deep dive on data for another series, because the things I want to talk about next are building production-worthy systems with Spring Boot, right? This is stuff that Spring Boot brings to the table that takes it well beyond what just Spring Framework itself gives you, okay? And a part of that is deployment, like for Kubernetes. So that fits very much in line with what I want to talk about. Another thing that I want to talk about, of course, is integration with monitoring systems and all that stuff to support observability, right? Again, that's another thing where Spring Boot is a step beyond what you can get out of the box with regular Spring Framework or whatever. The Fira code font is awesome. Am I not using the Fira code font? General appearance and behavior. Appearance. New UI. Where's my font? Oh, font is Inter. Oh, yeah, okay. Where's my Fira? Fira. Ooh, ah. That's Fira? And you think that's better? Everything looks like a typewriter. Oh, Fira. Okay, wait. Oh, I did the, okay, hold on. Reset to default. Okay, apply, good. Editor font, Fira. You're right, that's probably a lot better for the code itself. And then that's, yeah, you're right, that does look better. It looks more like a typewriter, which is nice. Oh, yeah, that's better. Thank you. See, this helps me, helps everything look a little bit nicer. Better for our readers, better for me, better for everybody. Oh, okay. Yeah, okay. Okay, so can you all read that still? Yeah, it looks like it's legible from here. That's what matters, I guess. So yeah, okay, let's talk about production worthiness, and let's talk about Kubernetes in particular. Kubernetes, there's, oh boy, there's so many things we could talk about here. First things first, though, we need the actuator. So in order to use the interesting stuff in Kubernetes, the first thing we're going to need is the Spring Boot actuator module, and we are going to have a whole discussion around the actuator, but let's just bring it in for now, just because we care about the stuff related to Kubernetes, okay? The actuator it's a management module. It brings in different endpoints. It gives you information about your application, things like the health, the metrics, things like that. And when it comes to Kubernetes, it brings us this health endpoint. There's a couple things, but the health endpoint is the most interesting part. So I want to say probes. I want to enable Kubernetes probes, okay? So let's restart the application. I've enabled probes, localhost 8080 actuator /health. This gives us a basic, status check with the actuator. So if I go here, curl -v, you can see it's giving me HTTP 200, right? But Kubernetes doesn't just care about up or down. It cares about two things: your readiness, which is the service ready to be put into production, right? That's the first thing. And then the second thing it cares about is your liveness. Is the service able to stay in production? Is it able to handle traffic? And so your health endpoint gives you both of those things. So I can go here. I can go to health liveness, right? You can see its status. Do this JQ HTTP. How do I not have that? Root install HTTPI. Oh, okay. Wait. Whoops. Okay. Downloading. I had to reset my homebrew recently, so this is a little unfortunate. Okay, so there you go. So you got status code up, right? 200 arrow code, a status code rather, and the JSON says up. So you get the status code as well as the JSON. You can parse either one. That's the liveness. The readiness probe, we saw that as well, I think. Readiness, right there it is as well. So So those probes tell you whether you're okay, and that's when you create a new deployment. And we're gonna talk about that as well. But github.com, developer advocacy, repositories, Twitter, whatever, Josh Long API. This is all public, by the way, if you want to follow along at home. Let me see, deploy. Kates. So when you create a deployment in Kubernetes, you've got to specify the container image, which is this right here. And you've got to specify the, a probe to tell you whether the service is ready. You've got the readiness probe here, starter probe, they're basically the same thing. And you've got your liveness probe, which is this. So I'm pointing Kubernetes to both my liveness and readiness probe to tell it whether the service is healthy or not. That's the first thing, is you've got this really good built-in support for probes, okay? What else? Configuration, right? So right now I've showed you that you can use application.properties. Application.properties is, one way to get access to your property values. And I showed you here, let's see, if we go here, let's create a bean application, listener application ready event, value logging listener, okay? And I'm going to inject a value from my configuration, okay? So we're going to call this test again. We'll say return event log.info. The value for test is, okay? So let's, the default will be test equals application.properties, all right? From this, okay, it'll be coming from that. However, so let's just restart that to make sure it all works. Whoopsies. Can't resolve placeholder in value. Wait, what? Oh, yeah, I was staring me right in the face. Okay, so the value for test is coming from. Oh, actually, wait, before we move on, let's talk about those endpoints. I should mention, you can see that printing out stuff here, right? Remember, we have those availability change events. Thank you, Ambu. Yeah, thank you. We have these availability change events. These are responding to events being broadcast by those probes, right? So the availability change event is, you have a, let's see, availability state, and we have liveness state and readiness state. So those events give you information about those states, right? So the service, I get an availability change event with some sort of subtype of availability state as the payload, right? So it's extends availability state, is it? I can get access to T, and then state you can see as availability state. So I don't have to, I can just ask, I guess toString is the only thing we got there, but it's a availability state. You can actually use that to ask questions about how, the service. Yeah, I would recommend, yeah, good. See, good stuff. Good stuff. So that listener tells you whether the service is available or not, whether it's healthy or not, and you can say, I want to get notified only of readiness state, for example, that kind of thing, right? So I can say, when I got the readiness state, whatever. So is there anything there? It's you can see that this is it's availability state. You can see it's an enum, right? And so I have enum readiness state, and I can actually ask it for the value. I can say, okay, get the value, name. There you go. So you can print that out. Let's try this. And service is healthy, accepting traffic, right? So it's telling me that. And here I just want to extend the availability state. Oops. Good. and just 2 strings since it's polymorphic and it doesn't know the fact that it's an enum. Okay. Okay. So basically, this is responding to those probes. The other thing to know is that you can actually set those probes. Did you know you can set the health controller? You can, first of all, the health controller. I'm not showing you everything here, so I can say health show details always, refresh. Okay. And when I show the details, you know, the service for the health service is healthy, correct, blah, 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 show the details, go back here. Back here, you can see the endpoint is now, it's not just showing this, it's showing I've got a disk space endpoint, I've got a liveness state, I've got MongoDB, I've got all this stuff related to my health on my application. You can create your own, so that's another thing. And so you can say bean health indicator, right? Return new health indicator. Return health.status iHeart Spring Boot build and restart, right? Refresh and you get this custom health indicator, iHeart Spring Boot. Now here I'm giving it OK status, but what if I said that something is down, right? Right, new illegal argument exception. Something's wrong. Right? Now we start that. Okay. You can see that the aggregate global status is down because this is down, right? So it's and also the status code now, because it's down, is a 500 instead of 200, 503 there, right? So that's very, very convenient, right? You've got this like standardized endpoint that gives you information about what's wrong in the system and what component is failing, and then your Kubernetes will see that, and so it'll automatically reflect that in the health liveness state as well. It'll say down, right? Status code 503. So Kubernetes will see that something is wrong, and it'll automatically take that container out of the rotation, right? And this is really powerful, right? It gives you the ability to write systems that do the right thing when something is sick. Right? As long as you configure those endpoints in that deployment, that YAML, in that way, then this just automatically gets done for you. It'll automatically create a new instance for you and put your service back on the path to being available. Okay. Okay, great. So now what? We've got our health indicators. We've got our we talked about the events. You can also force the readiness probe or the liveness probe up or down yourself, right? So let's say I create a controller here, class down controller, okay, at REST controller. So here's our web programming in action again. It's not really a REST controller though. It's just a controller with response body. I'm gonna call it down, void down. And here, let's say I want to manually force the system to shut itself down, right? So I'll inject the application context, and I'll say that there's something wrong. Publish this.context, and I'm going to publish an event of liveness state.broken. So I'm going to publish this event manually, and this is using that event publishing mechanism that we talked about earlier, right? Behind the scenes, I'm actually injecting this context. The context is being used here to get a pointer to an application event publisher, and then we're publishing an event of type availability change event, and the source is just whatever, and then the state is the state. So you can publish that event manually, or you can use this convenient static method. But either way, I'm publishing this event, and it's going to signal that something is wrong. So now let's localhost actuator health readiness. Okay, down. Whoops, let me fix the issue here. So fix that. Okay. So everything's up again. Now we have this down endpoint. Let's go there. So localhost 8080 down. Okay. Go back here. What is this endpoint that I created? Liveness state. So if I go to liveness, it's down now, right? And that's because I published this event. So let's just restart one more time so we can see the liveness probe actually. So it's up right now. Go to the down endpoint, hit refresh, go here, go down, right? So you can actually, you can anywhere in your code, in any business logic, in any controller, in any service repository, you can publish this event and force the application to become sick. And when it's sick, Kubernetes will take it down, right? So you don't have to inject anything. You can just publish an event. Very, very nice indirection. You're not coupled. You just need an application event publisher. Just inject that if you want. You can even do that here. Application event publisher, right? Publisher, and so you can say this.publisher.publish event, new availability change event. And I guess it's readiness or liveness state. And you can do that. So you can publish your own event as well. Same idea. So it's up. Go here. Okay. Simple as that. Very, very convenient. And you can listen for that event as well. So if something else publishes this event, like I said, that's what I'm doing up here. So remember, we've got this availability change event listener. This gets called when the application first starts up, but it also gets called every time that this happens. Every time this event gets published, you'll see that this gets a callback as well. And it says the service is healthy. You get the state, you get the string, etc. So you can see down here, it says service is healthy, broken. So we're now building services that are able to communicate that they're not healthy, that something is wrong in a consistent, transparent way, so that all the business logic, like when you see this event, whenever any component sees this event, you could write a controller, you could write a service. Maybe you've got something that you know needs to do something if this is down, right? Maybe you need to shut down something. Maybe you need to send a message. Maybe you need to like trigger an alarm or whatever. You can do that by plugging into this event listener, okay? So you get it. And so Kubernetes will do that for you. And the question then is, once the service is sick and once it goes down, what's going to happen? Well, imagine you've got like 1 million requests happening per second, okay? You've got lots of transactions happening, or even just 10 transactions, who cares? It doesn't matter. My point is, you've got more than one transaction, you've got more than 0 transactions happening, and Kubernetes thinks your service is sick. Now what? Well, it's going to do sigterm. Sigterm is like a Unix signal, the terminate signal. And then it's that's a suggestion. It's a light tap on the shoulder saying, please shut yourself down in an orderly fashion because we're going to purge the operating system process. And then it'll send sig kill. So if you don't shut down like really quickly, it'll start forcing you like kill -9 to kill the process. And usually there's very little time between one and the other, but that's okay because it doesn't take very long to stop things, right? But if you don't shut down in an orderly fashion quick, then you'll get sig kill, which is a forced, the memory from the operating system is just taken away. You don't have, it's not like you get a chance to shut down, you're just gone, period. You don't even exist anymore, right? As a process. So what happens to those web requests that are going on? What if you've got, some traffic, people are adding things to the shopping cart and there's a sessions and all this, right? Yeah, you can, so I'm glad you're enjoying it. Yeah, so you can create you can create your own custom endpoint, right? You can do all sorts of things there. The logic is completely up to you. Yeah. As for busy, we have broken and we have available basically. So it's kind of a binary there, but you could create your own custom endpoint and then plug into your own load balancer, for example, right? And that's easy enough to do with a service. What's it called? Not service. It'll come to me. Whatever. Yeah, it's easy enough to intercept how that gets managed. Hi, Syed. Good afternoon. Good morning. Good evening. So okay, yeah. So you've got this. What was I talking about before? You've got your Kubernetes application. The container orchestrator, Kubernetes, is going to kill your process. What happens if you've got traffic? Well, in this case, you want to make sure that if you've got people adding things to the shopping cart and they've got web sessions and all that, you want to give them a chance to you want to give your web server a chance to finish whatever it's doing, and then only after all the traffic has been drained off, then do you shut down. So one thing you want to do is, if you're using the Servlet API and you have a HTTP session, like we do, like we could have an HTTP session. One thing you might want to do is to use Spring Session, right? And actually, you know what? That's another thing we could look at very soon. I wonder if we could do that right now. Let's just continue this discussion for a minute, and we'll look at Spring Session. But that's a great idea. Let's do Spring Session. So Spring Session is a great way to plug into the HTTP servlet session abstraction, and then forward any writes for the HTTP servlet session to a distributed database like Redis, right? So now, if this node dies, if this JVM dies, the HTTP servlet session that was associated with it won't die, right? It'll still be stored in Redis. So when that same cookie appears in another node, another JVM, when the same user presenting the same cookie appears, it gets load balanced to another JVM, then that cookie will be connected to that same session living in Redis. So now the session just fails over, no problem. So that's one thing you want to do. But the second thing you want to do is you want to make sure that the traffic that you've already got is finished and that you don't create more traffic. So this gets us into the question of, how do we gracefully shut down our application in Kubernetes? And for this, we have a feature called Graceful Shutdown, okay? So shutdown equals graceful, right? So this lets you have a certain amount of timeout, right? Timeout per phase. And by default, it's 30 seconds, right? But what we're saying is we want 30 seconds between the sig term and the sig kill. So let's create a slow controller here, okay? Let's create a slow controller. Like this, slow, void slow, okay? And we're just gonna do the worst thing possible. Just create an artificial delay of 1 second, or even better, 10 seconds, okay? Okay, so we'll say log. Okay. That's left for J. We'll say log .info. Or maybe not 10. I don't care about 10. Var seconds equals 5. Seconds times 1. Okay. Okay. So slept seconds, blah blah blah. So about to sleep this many seconds, and then we slept. So we're going to make these requests, and we want to have 30 seconds of shutdown time. Okay, so let's do this. 10 seconds, or maybe 20. I don't know. Let's do application.properties. Timeout per phase is just 20 seconds, and we want this to be 10 seconds. Okay. So is that right? Yeah, we want this to be 20. We want this to be 20 seconds. Okay. No. How do I demonstrate this? Like, this is one of those things where you kind of have to see it. Let's just try it. Let's just see what happens. So we're going to run it. Okay. And there's I haven't made a request. There's no traffic, right? So what happens if does this do sig term or sig kill? Stop. Yeah, you can see it says commencing graceful shutdown, waiting for active request to complete. There was no active request, and so it shut down immediately, right? Okay, now what if we restart and we go to the slow controller? So localhost 8080 slow. Okay, so now we've got an active request going on. You can see here. Okay, good. We've got about to sleep 20 seconds. Now we'll stop it again. And then you can see it's Command F2. Good to know. So slept. It says commencing graceful shutdown, and you can see it kind of paused and then it says slept 20 seconds, and then immediately after that, this got called. So it waited up to 20 seconds. We already had something running, and then it shut it down. You know what I'm saying? So that long running request was allowed to continue going for up to however long we specified here, 20 seconds. Now, you have to make sure that you line this value up, the 20-second value. You'll have to make sure that you have that in Kubernetes as well. So termination grace period, I think it's called, Kubernetes. It's by default 30 seconds. So you have the grace period to handle you have 30 seconds to handle the term signal, right? Sig term. And as long as you handle that within 30 seconds, it's great. But if you want to like do anything else, then you need to like either change this default value and make sure that Spring Boot is aware of it as well. So here's how you specify it. Where is your Kubernetes? Here you go. Where's the configuration for this grace period? So you can specify the grace period in the deployment itself, or also when you like delete, you can say kubectl delete -- grace period equals whatever, and you can override that. But where's the deployment? Termination. Okay. Termination. Pods. Yeah, there's this. It's termination grace period seconds. I'm just looking for an example here. Deployment.yaml. Okay. Yeah, here you go. So you specify the container, the command, whatever, and then the termination grace period. So this is saying wait 5 seconds instead of 30, or maybe you want to make it like a minute instead of 30 seconds, right? You can make it a whole minute or 5 minutes or whatever you want. My point is you have to make sure that this value lines up with this value. So if you specify 60 seconds here, but you forget to specify that here, then Kubernetes is going to kill your Spring Boot app after 30 seconds by default, even though you specified this here. So these two values have to line up. Okay, that's very important. That helps you build services that degrade gracefully. Okay, so that's Graceful configuration, Graceful shutdown, and we've got the health endpoint. There's a whole dynamic there, right? I think the next thing tomorrow we should cover, or tomorrow is Monday. Yeah, we're going to cover configuration for properties, right? Like getting config tree configuration. Actually, let's just do that very quickly. We'll talk about one last thing here because we've got like 2 more minutes, basically. Okay. I talked about this configuration from a property file. We saw earlier that you can get configuration from environment variables, right? And that's very useful because it's easy to create a config map in Kubernetes and then map that to a deployment or a pod, right? And you can say, okay, the keys in this config map are environment variables. You can say env from and then point it to a config map object in your Kubernetes. And I think maybe we could even at some point we should go through the process of turning this into a container. Can you help me? I have a requirement. I need to call 2 APIs, but after I call the first API, I need to wait for 4 minutes to call the second API. I mean, I don't know. Are you using a scheduled executor service, right? That's easy enough, I guess. Okay, so we've got the config map. The config map can be environment variables, and that's easy enough. But another way that's very common in Kubernetes is to create something called a config tree. And so here, I might want to get configuration from a config tree. So import config tree. I'm going to point it to home desktop in. Okay, that last trailing / is very important. And what this is doing is I'm saying I want to import extra configuration, not just application.properties. Okay, and I want that configuration to be read in from this Kubernetes config tree format. And the way that works is I go here to my desktop, here config, cd config. Oh yeah, let me config. Okay. And I want to say touch server.port, or actually I'll echo 9090 to server.port. So the file is called server.port. It's on 9090, and you can restart this. Here we go. So now, where's my? There you go. It's started the service in port 9090, right? Instead of using 8080, which is the default, and that's because it's getting configuration from this format where you have a directory structure and you have files, and the files are the keys, and the contents of the files are the values. That's called a Kubernetes config tree. And so if you want to specify config maps as config trees, you can do that, and Spring Boot knows exactly how to use them. So you would write your Kubernetes specific configuration in that way as well. All right, my friends, we just covered a lot of stuff today. It started off great because of you all fixing my terrible code. So I appreciate that. That Gradle build is now a thing of beauty. I'm very proud. We looked at the embedded servlet engine. We talked about Tomcat. We talked about Loom, and we talked about the servlet abstraction, and we talked about how you can customize things. We talked about the role of the framework, the inversion of control, and dependency injection, and JNDI for retro kind of purposes. We looked at how to make your application more robust by using the Actuator. We looked at some of the endpoints. We looked at liveness and readiness probes, and we looked at the event publications that get done for you with Spring Boot and Actuator support. We looked at configuration. We looked at Graceful shutdown. We looked at just a lot of stuff. Today was a fun day. Thank you so much, everybody. I'm gonna go because I gotta go say hi to the family and stuff. They're all awake now, I suspect, and get on with the day. I hope you all have a wonderful Sunday, and some of you already, it's Monday. Hope you have a wonderful day and night and morning and afternoon and evening. And I'll see you all, 24 hours from now, maybe sooner. Maybe I'll come on back online today, but probably not. Have a great one, everybody. Thank you. Appreciate it. Bye-bye.